This is our first lesson in our data unit, where we're talking about how computers and programs make use of the data that we have all around us. As a very brief recap of digital information, we learned how pretty much every piece of information is able to be represented digitally as binary digits or bits. We talked about text, we talked about images. We can represent absolutely everything as binary. We can make our information become digital so that computers are able to store and process it. And we learned that once we have our data in a binary format, we are able to transfer it between our different devices across the internet. So this unit, we're going to be talking about data, and we'll be learning how computers are used to collect data, how they store data, how they manipulate data, and how they visualize data in order to answer various questions and gain knowledge about the world around us. So, data is information, so numbers, words, measurements, observations, literally any kind of information that has been placed into a computer-readable form. So let's talk about computer and human-readable information. Human-readable types of information are books. If you have a physical book or a physical notebook, you have a physical photograph. Anything that you are interacting with in the real world is generally going to be pretty human-readable. Human voices, images, lots of different things are human-readable, where things that are computer-readable, that's pretty much just binary. So we need to translate all of our human-readable information into computer-readable information so that our computers can process it. And that's why we discussed that in digital information unit as a whole. So our challenge, like I just said, is translating back and forth between those things. Using all the information we learned from the digital information unit, we learned how to represent all kinds of different things using binary. For example, we talked about how we can represent an image using just ones and zeros by using the RGB values. So if I have some random image, I have a picture of a monkey, I can take, for every single pixel, every pixel has a color and has a position. That color can be represented by the RGB value, red, green, and the blue. Those numbers can be represented in binary, and so we can represent the entire image using just zeros and ones, using this process for every single pixel in the picture. So we get a whole bunch of ones and zeros, and some that overflow off the bottom. Now, as our world grows ever more digital, as we get increasingly digitized in our lives, we're finding more and more ways to turn human-readable, unstructured data into computer-readable, structured data. Things like human voice. We are learning how to let computers actually interface with human voice with like Alexa or Siri or the Google Assistant. We can turn song files, video files, image files, text files, spreadsheets with measurements and statistics. These are all things that we are learning how to turn from human-readable information into a digital format so that our computers are able to read through and process this information, all this data. Once we have structured our data in some uniform way, we are able to write programs to store, process, manipulate, and or visualize that information so that we can maybe learn something from it. So pretty much every program that we write or that exists is going to interact with some data in some way. So let's say we have some kind of input data. We could have a spreadsheet. We could have a picture. We could have the person who is using the program's mouse movements. We could have keyboard inputs. We could have an HTTP request. The types of input data, absolutely limitless. If there's a type of data, there is a program to process that kind of data. So our program is going to take in the data, It's going to analyze it, going to manipulate it, do something with it, and it's going to produce some more data as output. So we get ones and zeros as our input, we process all those ones and zeros, and we spit out more different ones and zeros. We could, in turn, spit out a spreadsheet. We could spit out some picture. We could spit out some sounds. There's all kinds of different outputs, just like there's all kinds of different inputs. So, like I said, once we have our data digital, we are able to have our programs manipulate it in any number of different ways. Remember back to the digital information unit, we could change the contrast of an image. We could darken part of it. We could lighten part of it. We do any kind of calculation with the RGB values to make them different, to filter our image. We can even write programs as we get more and more advanced with the programs we write. They are able to recognize things like edges along a shape. They can find shadows. They can even find faces if we train them to do that. So there's different computer algorithms for like automatically green screening you, even if you don't have a green screen behind you. It'll locate the edges around your body and just replace everything else in the image with something else. That's kind of what Zoom does with the digital backgrounds. It uses a computer algorithm to recognize the outline of where you are and replace everything else in the image with that background. Now, why is data relevant? Why do we care about data and digital information? So data and pretty much all information are both used in the creation of knowledge. Raw information does not tell us anything by itself. If we just look at a whole bunch of numbers, they don't mean anything. We need to do some processing, we need to do some evaluation, or we need to do some computation with this information to understand what it represents. We need to apply labels, we need to do all kinds of different things to understand what these numbers mean, to gain knowledge from this data. So we can run computations on the data that we have to potentially recognize patterns. We can gain new insights and knowledge. We could predict future events based on past ones. We can even realize and solve problems based on the information that we've collected. And like I said earlier, we live in a time where data is everywhere. Our modern day, everything is becoming digital, so data sets are growing larger and larger and larger every single day. There's information about all kinds of things from all over the world that's being collected, stored, and processed in various ways. Information like financial transactions, all kinds of personal and medical data, information about people's web browsing history, and just natural measurements about the world around us, how many clouds there are, what the humidity is around us. All these kinds of things are being tracked constantly, whether we know about it or not. So these huge, huge data sets allow us opportunities to identify trends. We can make predictions about the future. We can make connections that might not be readily apparent. But we need to do processing about this data to understand what it is revealing. Just raw numbers don't tell us anything. So computing tools are essential when we're working with large data sets, when we're working with big data, because we as humans are not nearly as efficient at doing processing as computers are. Computers can process information way, way, way faster than humans can. So computing tools allow us to search, filter, store, and visualize data, among many other things. So let's say we have a farmer who has a tool that they have sensors all across their land. These sensors are going to capture information. They're going to send it to this central database, and they have a whole bunch of numbers. There's a program. They can have this program to read all these numbers and then perform a visualization. You take all this data that they have do some calculations and output some visual thing so that it's human readable, so that the farmer can look at this heat map and say, let's plant more of our crops in these dark green areas because those are better or something. I don't know what exactly this is representing, but it's sealed data. Obviously, it's going to be representing something. So we're taking the information from the sensors and making it human readable by providing an image. We can use computing tools to track how diseases might spread and make predictions on how it's going to grow and maybe find ways to prevent the spread. We can see all these red dots representing the prevalence of people to catch a specific illness. You can see probably centered around hubs of where people live. The larger cities are more likely to be hit. And if we look, the East Coast is lots more red than the West Coast. So maybe it affects colder climates more than it affects warmer climates. So this is all information that we can glean way easier with this picture of a map with these different colored dots. We can gain information way better than if we just had a huge spreadsheet full of numbers. So with these tools, we're able to learn more information. And while this is having access to all this data and all these tools is awesome, there are definitely some concerns that are raised as a result of all of the data being collected and being swirling around the world around us. So one of the problems that we are faced with is storing and processing huge amounts of data is challenging. So a solution that has been developed for that is databases, which are systems that are designed for storing huge quantities of information. And then to interface with these databases, we have database languages like SQL or SQL. So that we can access our data in a programmatic way. We can use this computing language to actually get specific subsets of our data. Another concern is that keeping data private can be challenging, and that's why, like in the last unit, we talked about encryption. We want to make sure that any data that we are transmitting or even storing is encrypted so that if someone gains access to it, they can't actually read it. They can't glean any information from it because it's all scrambled up. And keeping data anonymized is also important because if data can't be tied to someone in particular, it's much harder to make any assumptions about any particular person. And a big concern is that we are really not sure how much of our personal data is being tracked day to day. So I know that even I don't really do this, but actually reading the privacy policy for things that you're signing up for will tell you how your information might be collected, how they might use your information. There's an adage, if the service is free, you're probably the product. So like social media, they are collecting all of the information that we give it and then probably selling it to advertisers or other people online who might want to know more information about us. So reading the privacy policy can let you know what exactly it is that you're signing up for, what information about yourself you are signing away by signing up. So as we go through this unit, we're going to talk more about these different aspects. We're going to talk about data visualization, data processing, all this fun stuff. But there we have it. Any questions about our intro to data? Cool. Cool. All right.